Hello. In this video, I'm going to be showing you a few examples of the chain rule. So if you look here, we're going to start with y equals sine of x to the 5, and we're going to differentiate with respect to x. So for the first one here, we notice that if it was sine of x, well, the derivative would just be cosine of x. But unfortunately, we don't have sine of x, we have sine of x to the power of 5. So we use the chain rule, and we write y prime is equal to, and it's the same methodology, we still write cos of x, but of course instead of an x we have an x to the 5, so we write cos of x to the 5. And then the chain rule says we need to take the derivative of the inside function. We need to take the derivative of x to the 5, which is of course 5x to the 4, and we multiply the two. So let's take a look here at example 2. Again, we have secant x squared. If we just had a secant x, we know the derivative would be secant x tan x. So we use that pattern to find f prime. So we would have here f prime x equals secant x squared tan x squared. And then we have to multiply by the derivative of that inside function. So we multiply by 2x. Okay, we'll do one more example here. For number 3, we have y equals cos of 5x to the 4. So again, we look at this part on the inside function, and we can just imagine covering it up. We just put our finger over top of it, and we just look at the outside function, cosine. We say to ourselves, okay, y prime will equal negative sine. We rewrite that inside function, and then we multiply by the derivative of the inside function, which in this case will be 20x to the 3. Okay, we're going to scroll down here and take a look at a few other examples. So let's attempt number 9. We have e to the 5x squared. Again, we want to cover up this inside function, and just imagine e to the x. The derivative of e to the x is simply, well, e to the x. So we get e to the 5x squared. And then we multiply by the derivative of that inside function. So we multiply by 10x. Let's take a look at number 10 here. Y equals e to the 3x to the 5. Well, we know the derivative of e to the x is e to the x. So y prime will equal e to the 3x to the power 5 times 15x to the 4. Okay, let's take a look at question 11. For this one, we have multiplication. This is actually a product rule. So when we do the derivative, we have to say, okay, let's take the derivative of the first. That will be 3x squared. And we'll leave the second one alone. So that'll be e to the 3x squared. Plus, now we leave the first alone, x to the 3 plus 3. We have to take the derivative of the second function. The derivative of e to the 3x squared. This looks like question 9 and 10. This is a chain rule problem. So the derivative of e to the anything will be, well, just e to that anything. So e to the 3x squared. And then we have to multiply by the derivative of the inside. So 6x. You can go ahead and try question 12 on your own. We're going to skip forward to another question in the handout. Let's take a look at question 20 on the handout. We have tan 5x to the 3 times cosecant 5x to the 4. Again, this is going to be a product rule because we have tan of something times cosecant of something. So using product rule, f prime of x will equal the derivative of the first. So, we have to take the derivative of tan thinking back to our rules, that'll be secant squared, and we rewrite the inside function. Then the chain rule tells us we have to multiply by 15x squared. And then we have to leave the second function alone, so we just multiply by cosecant 5x to the 4. Plus, I think I'm going to run out of space here, so we'll kind of do it like this. Plus, leave the first one alone, tan 5x to the 3, times the derivative of cosecant. Well, that's going to be negative cosecant of 5x to the 4 times cotan 5x to the 4. And then again, we have to use that chain rule, because see here we have the 5x to the 4 on the inside function. So we need to multiply by 20x to the 3. And then don't forget to close our bracket. Alright, one final example here is we're going to do question 28. Y equals e to the 3x to the 3. We actually have so many exponents there, it's kind of hard to see that final 3 up there. But it is e to the 3x to the 3. Now, how might we find the derivative? Y prime. Again, using the chain rule, we're going to cover up all of this stuff here and just look at the outside function e. Well, the derivative of e to the x is just e to the x, so we rewrite e to the 3x to the 3. Then the chain rule says we have to multiply by the derivative of the inside function. The inside function here is the e to the 3x to the 3. So the derivative of e to the 3x to the 3 will just be e to the 3x to the 3, because the derivative of e to the x is just e to the x. But again, we still have one more inside function to go. So we have to use chain rule again and find the derivative of 3x to the 3. That will be 9x squared. So that's our final answer. Thanks for watching.